You're now plugged into the Delphi podcast.
Hey everyone, it's Tommy from Delphi Ventures, and today I'm thrilled to have on Sam Lehman, who wrote one of the absolute best posts on AI called The World's RL Gym, what the RL Renaissance means for decentralized AI. Sam, how are you? How's it going?
Doing well. Really happy to be here. Thanks for having me on.
Sam, you're a partner at Symbolic Capital. You're a crazy good AI researcher. Tell us a bit about yourself before we dive into the post for everyone.
Yeah, so I've been at Symbolic for about 3 years now. Sort of start with the fun around inception. Have been investing across Web3 broadly over those 3 years. In a past life, I worked in TradFi. And even before that, I actually opened a craft brewery. So I've done a bunch of different things. But now with Symbolic, I've been very focused on the world of decentralized AI. It's a huge part of our fund's thesis. We do pre-seed seed investing mainly. And I've just really been enjoying exploring this world of Web3 that's, for me, provided the most excitement that I've ever had investing in this category.
Yeah, I mean, our funds are definitely aligned on the thesis there and the focus. So I'm excited to talk to you on this. Let's start with the beginning of the post and see where the conversation takes us. But let's just open up with, you give a really good brief history of AI and ML scaling, right? The pre-training scaling laws, the importance of data in this training, scaling up these models. Maybe just like walk us through the genesis of the history of the AI scaling stuff.
Yeah, definitely. So I think about this history in three phases. Phase one being focused on pre-training, phase two on inference time, test time compute scaling, and then sort of this new emergent phase, which is RL scaling, which is what the post is focused about. And essentially, to sort of zoom out initially, my goal with the piece was to, starting with this new RL renaissance that's upon us, trace my way back to figure out how we got here, what came before, and specifically, what levers were AI researchers pulling to scale and make more performant models, and how has that changed over time? How do we get to this new paradigm, which feels like the paradigm of RL? So we started with pre-train, which is essentially being able to throw more data and compute into models at pre-training. And as long as we were able to increase those two factors to end up with more performant models. And there was a lot of work back in 2020 and then 2022 where very early researchers at OpenAI, some of which you probably know, went on to found Anthropic, and then later by DeepMind researchers, they basically sort of codified these rules and sort of found a very clear scaling law, which is essentially the ratio of data to the eventual parameters you want to have that model end up with. And essentially, we found that, most of these models at the time, way back when, had too many parameters relevant to the data that was going in. So we needed to basically increase the amount of data and then sort of addition, the amount of compute to get to better models. So that was sort of the pre-training era. And then, fast forward to, 2023, 2024, we had these reasoning models come out, and we realized that there's now this sort of new paradigm upon us where by allowing models sort of more time to think, we could get more performant models. So now it just wasn't, you had to put more compute and data in at the beginning at pre-training, but actually once you had the model, you could allow the model to think longer, to use more compute resources while it's solving problems and get better performance. That was the second phase, and that took us to the RL phase.
Yeah, it's pretty crazy. So basically you found out that in the pre-training phase where these AI labs are just throwing, mass compute, basically the 0 and 1 parameters in these models, there was too many parameters for the amount of data going in. So there wasn't enough data to effectively change those zeros and ones to make a performant model. Is that what happened?
Yeah, exactly. They're basically by codifying what were called sort of the chinchilla scaling laws. They found that the optimal ratio of data to parameters was around roughly 20 tokens per parameter. But before they sort of codified these scaling laws, that ratio was off. There were too many parameters relevant to the data going in. And that sort of opened researchers' eyes to this idea that we had to get more data going into these models.
That's awesome. So that's phase one, which you just covered. And then phase two is this inference time, test time compute scaling, like where the model is sort of thinking in real time. Walk us through that a little bit more, because obviously everyone's seen like ChatGPT think, but I don't think they have like the nuance that you have with it.
Yeah, so basically, up until roughly end of 23, 24, you had more of these sort of down the middle, straightforward LLMs where you would put in a query, get your immediate response back. The model had sort of one shot to think, solve problem, give you your output. And then through techniques that have become more apparent with time, researchers were able to develop these reasoning models that actually had the ability to use more compute at time of inference, to spend more compute to think longer, to check their work, to explore different pathways of solving a problem. And we found, sort of similar to how there were pre-training scaling laws, where you scale up data and compute and get a better pre-trained model, you can also scale up the amount of compute a reasoning model can use to think, to allow it to basically think harder, think longer, and get better answers. And again, thanks to Google DeepMind researchers, there was a paper called Scaling LLM Test Time Compute that showed that you could have a smaller model, but allow it to think longer, and it could outperform a larger model. And so this showed us, okay, now there's a new lever we can pull to get better performance, and that's allowing these reasoning models to think longer.
Yeah, it's so cool. It kind of came out of left field a bit, because everybody was just thinking like, let's just build bigger data centers, let's throw more hardware, let's throw more data. And that was sort of, I think where everybody was just going to spend the next 10 years. And then inference time or test time compute just came out and kind of shocked the world that you could just think at the time you asked the question.
Yeah, and there were some pretty amazing sound bites that sort of came out of this new paradigm, and that's sort of roughly around the time when Jensen was on the BG2 podcast and said something like, inference is going to be 1 billion times bigger than pre-training. And so we had the combo of sort of, having more compute at time of inference, also just having sort of more consumers hitting these models, demanding more inference. There was this like perfect sort of conflicts of, oh my gosh, okay, all the compute is going to be going towards inference now. And that was sort of, again, sort of marked a bit of a paradigm shift.
Yeah, it is pretty crazy, because originally, before the test time compute stuff came out, I assumed inference would be huge or bigger than training, in a sense of just raw quantity of requests to the models, like just pure asks. I did not think it would ever be in the thinking time per request.
Yeah, exactly. And so this was a really cool sort of new, again, vector in which we could scale up models. And in the paper, I sort of show this graph where you have scores on the ARC AGI eval, which is a popular way to test sort of the abilities of new models. And they're pretty flat as you get sort of, every new GPT-2, GPT-3, GPT-4 release. And then there's this sort of near parabolic shift when the reasoning models come out, and they just crush this eval, because these models are now able to expend so much more compute, and they're actually solving the problems. And again, that it resulted in a real fundamental shift in the whole industry.
Yeah, it is pretty crazy. I mean, just to describe the graph a bit, you have the ARC AGI score, and you have ChatGPT 4.0 at, let's call it, I don't know, maybe this is 5 or 6%, and then you have O3 at 90%.
Yeah,
a couple months later.
Yeah, it's crazy.
So walk us through phase 3. So we talked about pre-training, we talked about inference time. What happens at the phase 3 here?
Yeah, and so what I use is sort of the DeepSeek moment as a catalyst for a lot of this, and it is, I think, when talk about RL for LLMs became a lot more mainstream. I want to be really clear. RL has been around for a long time, and all the frontier labs were doing RL, specifically RLHF, on their models around this time. And DeepSeek didn't. They weren't the first to use RL. They just sort of used it in an innovative way, and then in a sort of innovative and very elegant way, I would say. So essentially, what we saw with this DeepSeek moment was they took a very performant base model, and through, which we can get into more if you want, their very elegant sort of GRPO focused RL process got a base model to develop extremely powerful reasoning capabilities through, again, this RL process. And it showed that you could use RL on LLMs to take one model and make it much, much more performant to sort of incentivize and elicit this really powerful reasoning behavior. And to do so in a way, and this is like the really important thing, with limited human intervention. And that was a huge, huge sort of breakthrough with what DeepSeek published, was that the processes they used had minimal human intervention.
Yeah, it's crazy reading your post, because I remember when DeepSeek not came out, because it came out like 1 or 2 weeks before, but when that Sunday NVIDIA crash was about to happen, that Monday morning when DeepSeek really went viral, everyone just claimed it was distilled off OpenAI. But it sounds like, from what you're saying, like they took a pretty novel approach to train R1 in the end. Would that be fair?
Yeah, from what I understand, most of the industry was using PPO, and then DeepSeek showed the viability of GRPO, and since then I've seen a lot of other researchers, engineers implementing GRPO in their own RL processes. I think it's important to note here, like, so much of this is extremely new. In the wake of DeepSeek, I just saw this massive explosion of different RL algorithms on my timeline. Everyone's like, oh, there's the nth PPO, PO type thing. What's going to be next? So there's been a lot of experimentation, but GRPO was a really sort of exciting new algorithm that the DeepSeek team implemented for their RL process, and a lot of teams have been using it.
It's really cool. So I wasn't really too aware of this until I read your post, but you lay out sort of the DeepSeek stack, where you have DeepSeek v3, which is their 671 billion parameter, I guess we'll call it a base model. Mm-hmm. Then you have R10, which is the model they trained using v3. And then you have DeepSeek R1, which is like this cleaned up version. I'd love to maybe walk through this process a bit. Like, maybe your like key takeaways on going from that base parameter model to this smart reasoning model, like just that flow.
Definitely. And I think this went maybe a bit under the radar, because there was basically DeepSeek, they published v3, which was this mixture of experts, sparse model, I think around December. And then it was about a month or so later that R10 came out. So they were actually staggered releases. And so it's confused some people about what was actually going on, I think. The way I would think about it is essentially the DeepSeek team had their base model, v3, and then they performed two similar but slightly different RL processes on that base model to end up with these reasoning models. One process, you ended up with R10. The other process, you end up with R1. What was really exciting is sort of what they did with R10, which is where you get sort of that removal of human intervention. With R10, they essentially took the base model v3, they fed the model a bunch of questions, mainly around math, coding, and were able, because they were pretty verifiable domains, just say, the model gets a 1 if it's correct or a 0 if it's incorrect. And they allowed the model, through trial and error, to solve a bunch of those problems and get that binary reward and learn how to become very performant at solving these types of problems that was being fed to it. Usually, you would either feed the model a lot of sort of highly curated human-generated data to show how it should mimic the way that humans might want to get their outputs. But with R10, it was literally just, here's a bunch of problems, start thinking, figure it out. And through that process, the model learned to think longer and to use more compute while it's thinking. And with that, became much more performant. And that was I don't want that sort of to go under the radar. That's a really exciting innovation.
Yeah, no, that is. So just to rehash this a bit. So what you're saying is like they gave R1 a bunch of questions and then they opened up the back of the textbook and gave it all the answers, but it did not tell it the process on how to go from question to answer. And that's how these models are usually trained. Is that fair?
That's exactly right. And then this is also very important to note. What you end up with R10 is a very performant model. It's very good at solving problems and getting the right answer, but it's not very human legible. So the actual answers it gives and the reasoning traces it generates, sort of the chain of thought that you can look at, it would mix languages, it wouldn't use proper syntax. It's not a model that's great for everyday interaction with humans. You basically have this sort of like wild child that was somewhat uninhibited by human preference that got super smart, but isn't exactly, been conditioned to fit what humans would like to interact with.
But Sam, but even though the model is switching languages while it's thinking, it's still getting to the answer.
That's right.
That's nuts. Yeah, it's hard to understand. Like thinking in English, then Chinese, and getting to an answer is nuts.
Exactly, and I think there's something I've been spending a bit more time on researching is sort of how the sort of injection of human data, of human preference into the RL process could potentially inhibit the creativity, expressivity, and ultimately the performance of models, right? I was actually recently sort of learning more about the history of AlphaGo and AlphaZero, and the Google researchers found that initially they trained this model to be a great Go player, which is a very complex game, but one with sort of verifiable rewards. And at first pass, they gave the model a bunch of examples of how humans play Go, and then sort of gave that because they felt like they needed to have some reference to start the RL process and then become a performant model at Go. They later went back and they removed that sort of interjection of human data, and they let the model know the rules and have verifiable rewards and just learn to win Go without that sort of human interjection of data. And you got an even better model, a model that would make moves that no human could do themselves, would think of themselves. And that's how you get this sort of I think it was called like move 37, which was this move that no human player would ever make that blew the minds of all Go players because this model was doing something that humans wouldn't think to do. And so I worry sometimes that, or I wonder, maybe we should just let these models be a bit more weird, be a bit more curious, explore a bit more, and not chain them to human preference, human data.
Yeah, it's crazy that Move 37 was so long ago, and here you and I are talking about this. Like, I mean, you mentioned it's not new, but yeah, I don't know. Like, why is it such a big deal now? Is it because we're all able to use it and understand it? Like,
yeah, I think one, RL is very well suited to like games, to chess, to Go, because the constraints were very clear. The reward state, the rewards are really easy to calculate, right? You either win or you lose the game. It's been much harder to fit that to LLMs, to everyday human interactions. And it's taken some time, I think, for the industry to figure out how to fit these RL methods that were sort of great in certain contexts into this new chat tool use, problem solving era that we're in now. And it's also, I think, why we've seen so much of the gains be made in coding and math, because those are the most easily easy to verify in a binary way. And I think there's a lot of challenge right now. Okay, how do we use these RL techniques in non-verifiable domains, in creativity, poetry, writing, domains like that?
So, Sam, you mentioned that DeepSeek was trained on like having this big supply of questions and answers, right? Does that imply that these models can't get good at answering new questions for which they don't have the answers to? Like, I'm trying to figure out like where the gap is between, training these things on question and answer and then solving unique and new things for which they've never seen an answer for.
Yeah, they're good at sort of the domains in which they were trained. So I want to be clear, a lot of this work is still reliant on having really high quality question and answer pairs to start with and the correct results. There's been limited work on sort of how training a model to be great at math and coding generalizes. So if you get a model, a bunch of data on math and coding, and give them those sort of question answer pairs, will that model then become good at creative writing? I know you've had Travis from Ambient on the podcast recently. I think he's very bullish on generalizability. I think I'm personally a bit more skeptical. I think it's a bit under researched, and it's a big problem to solve now. I think generalizability is going to be a huge new theme, as well as being able to sort of adapt the RL process to non-easily verifiable domains as well. And I think there's a lot of sort of unsolved questions there.
Yeah, definitely out of my range, but I'll definitely maybe get you both on to chat through it. And then just one of the things you mentioned during the post that I really want to spend a little bit of time on was you mentioned it's about like halfway down your post that DeepSeek, the length of the response, I think it thinks more and it thinks longer, right? Like that just seems weird, right? Like, so like if it gets the 10 questions on the 10th one, it's thinking longer for that one. Like, why is that? Or am I describing that wrong?
Yeah, essentially what happened was, as it was getting more and more questions and it was being rewarded for getting the answer right, it started to sort of be incentivized that the longer it was thinking, the more right the answer was. And so there's this beautiful chart in the DeepSeek paper where on one axis you have steps, so basically, how many questions have been fed to the model, how long it's been post-training for. And on the y-axis, you have the length of response. Basically, as it's getting, as we're kind of going out on the x-axis, it's learning to think longer. And I think, if I recall right, there's what's called sort of the researchers called the aha moment, where there's a reasoning trace where the model it's generating this trace. It's thinking with text essentially, and it says, wait, I need to think about this longer, or I should think about it this way. And it's literally telling itself, wait, if I think more about this, I can get the answer right. And you see that play out in this chart where the more it learns to think longer, because it tends to get answers more right with these longer traces. So that's a sort of really beautiful moment in the training process that the researchers called out.
It is kind of crazy. It sounds like, historically I always thought that proprietary data or just access to, large swaths of data or go forward new data was like one of the biggest moats. But from what you're describing, it really sounds like these reasoning traces or this flow of thinking is the most important sort of data source or something. Is that fair? Or
I go back and forth on this a lot. In the piece, I talk a lot about how, essentially the RL process is you get the model to generate synthetic data, you verify that data, and you take those verifications and allow the model to learn from it and become more performant. And you can sort of get this virtuous cycle where it's like you sort of coax the model to generate this data. You verify it, it feeds back, it makes them all more performant. But at the same time, I've maybe adjust my thinking a bit, because to get the model going, you still need to get it really high quality question and answer pairs. And there was talk of the DeepSeek team just spending hours and hours on end generating math and coding pairs themselves. And so I think the next push is going to be figuring out how can we get away from this reliance on really high quality human data to get sort of this flywheel started, and just allow for more of the this virtuous cycle synthetic data all the way down to play out.
So you brought us to a fun part of the podcast in your post. It's just, I guess, like that next step to creating this decentralized reinforcement learning type network. I don't want to give any details. Would love your take first, but what is this, like, this convergence here that you're talking about? Because this is an interesting avenue.
Yeah, so I get to this part in the post where my goal was sort of to map out how all this fits together, how you would decentralize the RL process, but also why you might want to. And I break it into these sort of three parts that I sort of name in a bit of a cutesy way. The first part being the foundation, the second being the gym, and the third being the refinery. And I can sort of explain these pieces, but essentially the foundation is you need a great foundation to do RL on top of, and that foundation is a performant-based model. And I think that if we're going to decentralize this whole thing, might as well decentralize the pre-training for that base model. You need a gym to sort of elicit the different types of reasoning behavior of different sort of LLM cognitive strategies. You need to generate that high quality data. And then the last part, the refinery, is you actually need a network to do the optimization, the actual post-training itself. And so that's how I map things out.
No, it's a really helpful mental model. You have your base model, right, at the bottom, and you want to do decentralized training, like Noose, Prime Intellect, Jensen, take your pick to do that. Then in the middle, you have the gym to generate all these high quality reasoning traces, which we just discussed, and then the refinery to like use those to then, go back and train the model again. I'm really curious your take on the gym part. Just like an environment to generate diverse, high quality reasoning data. Like, is that a university? Is that Microsoft's research team? Is that the Delphi research team? Like what are these environments? Like, how do you see them operating?
Yeah, so the idea of an RL gym is not new. Essentially, what it is a digital environment where you can have a model try out different strategies and sort of solve a given problem, a challenge, in many different ways, sort of to have that sort of arena with enough of guardrails around it to steer the model to find the best strategy. And so one of the first examples of an RL gym was the OpenAI gym. It was an old project they had where it was literally an environment for devs to test out different RL strategies on like basic tasks. There's something called like Carla, which is sort of an environment to try out different strategies for self-driving cars. And so these have existed before. What I call for is, now that we're seeing how RL can work for LLMs, and LLMs have applications across many, many, many very diverse domains, we need to spin up environments to allow for the RL process to play out across many different domains. So there could be, environment that's great for math, a set that's focused on creative writing, on medicine, on drug discovery, on physics. the idea is to have many environments that can elicit the best strategy for a given domain. And then you need to pair with that robust verifiers. So you need a way to have sort of environments eliciting all of this sort of behavior amongst the models to solve problems. And then you also need verifiers, which say if this was right or wrong, or to pick the best strategy and therefore elicit the most performant behavior.
So Sam, how do I contribute a reasoning trace to the gym? Like, let's say I'm a venture capitalist. I invest in projects. Like, I wanna I wanna contribute to this gym. Do I like upload my investment committee doc and like the outcomes of those projects on if I made money or not? Like what is the process for adding, for adding to a gym?
Yeah, so the concept would allow you to contribute in different ways. My idea would be you have an open platform where anybody can create environments that then allow other people to bring models to that environment and to generate synthetic data, generate these reasoning traces, have those traces get verified, and then allow sort of that corpus of data that has that's been verified and contribute that to the training of new models. My hope is that this can be done in a very open, decentralized way.
That was my $1 million question for you. Like, if we're looking at you're in OpenAI, you're in Anthropic, take your pick of an AI lab, and you're looking at this specific issue where, hey, we need a lot of reasoning traces to perfect our models. Like, I guess my main question for you is why is it better to do that decentralized than do it from their perspective?
Yeah. And so this gets into a bit of the philosophical, but I think an also sort of more, fundamentals driven argument. But a lot of my belief in this domain comes from a concept that the USV team uses where when they believe that the best companies come out of areas where you're unlocking sort of innovation at the edge, where there's the ability for sort of people to try out different things in a very open way. RL, I think, is uniquely well suited to that idea because the whole process is about allowing for models to explore different strategies to get those different attempts verified and to learn from that and to improve from that. And I personally think that you want a platform where as much experimentation across as many different domains can happen as humanly possible, because only then will you elicit the absolute best possible strategies. I've been sort of working on this analogy in my head where if I think about a closed source frontier lab trying to elicit the best RL strategy, it's like taking a super smart kid and putting that kid in a room alone. You give them the best tutors and the best textbooks and resources, and ask them to solve the world's hardest problems. That's kind of what it feels like sort of the frontier labs do. It's very closed, but they have so many resources that they might be able to get to the best answers. The flip side, the more sort of open side of this would be a school where the smartest people in the world can attend and they can collaborate with each other. They can share ideas. They can, figure out the best way to solve problems together. And I tried it this way, you did it that way. I think yours is more interesting. Let's go down this path. And I think I'm very confident that's going to lead to the most progress, the best possible strategies when you have that open collaboration and exploration.
No, it's a fair take. Maybe something that's a little confusing for me. I'll run by you to see if I'm on the right path here. But when I'm thinking about reasoning traces, I get a little confused when I'm thinking through the data that an OpenAI has to use from just people globally asking it questions and reaching conclusions, right? And there is sort of this, supervised human involvement of, here's my question, no, here's more data, this is the way I want to solve it, and then bam, their answer. Would you consider that like a reasoning trace in its own right, or is that sort of separate from what we're talking about here?
Yeah, so a reasoning trace is just the chain of thought string that the model created, produced to end up at its eventual answer. So if you've ever seen DeepSeek was the one that sort of pulled back the curtain. They showed them all thinking, where it would say, oh, the user is asking this question. I think that I should solve it with this strategy. If I were to do that, I would, add these two numbers together, and then I would divide by this. And it's basically like that full chain of thought. And those traces are, important to feed back into the model to continue to incentivize and elicit, better and better reasoning behavior to get to the eventual right answer.
Yeah, that is cool. I get a little cloudy on trying to figure out how people globally will contribute to the gym. Like what you're saying makes sense. I'm just like, having hundreds of millions contribute, I get a little rough on how it happens.
Yeah, so it's not about like I'm going to sit down and I'm going to handwrite out a bunch of reasoning traces. It's more the sort of the world's gym is this idea that you can allow people to create different environments to put models into, to have those models generate the reasoning traces, for those traces to be verified if they're right or if they're wrong. And for that, sort of that platform to allow for the elicitation of the best possible reasoning strategies. It's about having like many, many diverse environments created and creative ways to verify what's right or what's wrong or what's most preferable in an open way.
That is pretty cool. I guess if you had to take the other side of the argument, is there any way that you think an OpenAI could use like their funding or offer people free access in return for these traces, or anything that you think would sort of go against the thesis of a global decentralized RL gym?
I mean, I think what they have and what they're clearly doubling down on is distribution. They have so many users on their platform that, with O3 coming out now, trying and sort of getting these models to use tools to sort of start to move into different parts of reasoning, different types of problems. And they have now sort of this platform that feeds them so much very, very valuable data. I worry about sort of one that being a real advantage of just having the most users generating this great synthetic data without the users really even know it. And so, they are going to have the volume for sure, but I still think at the same time, the downside is that you're hoping that one giant centralized company can go after and try to solve the right problems, go after the right domains. I'm sure they're working on non-math and coding focused stuff. Obviously, they're doing a lot of multi-model innovation as well. But I'm sitting here, still waiting for when are we going to get real progress in non-verifiable domains? Where is the progress in creative writing and things outside of math and coding going to come? And if there was a platform where anybody could explore those things and we could figure out different strategies to verify those domains, I think we're more likely to get to the best models for those areas faster than one centralized player.
That's cool. And it's not really hypothetical, right? Like I know you mentioned that there are a couple of projects that have done this in the past. And I think in the post, you also mentioned Prime Intellect has Synthetic One, which has 2 million reasoning traces. So it sounds like this is very much moving forward as a concept.
Absolutely. Yeah. So there are two companies that I call out in the piece that are sort of starting to make efforts in this area. Prime Intellect's been at the forefront of a lot of innovation, decentralized AI. I assuming a lot of people listening might know of them, but They've been working on Decentralized RL. They just had a big release on Synthetic 2, which is their new Decentralized RL run. But earlier, they'd announced this project called Genesis, which was an open source library of many, many reasoning traces. So anybody can get access to these types of traces that can be used to post-train models. The other project I called out was called General Reasoning. It's not a crypto company. It's a open source library platform, where anyone can contribute and verify reasoning traces in many different domains. So across math, medicine, physics, writing, etc. I think it's a super cool project. It's sort of for the greater good right now, but I mentioned in the post, could this be monetized some way? Could people be getting rewarded for either generating traces with models or by creating new environments that elicit more performant model behavior?
That's really cool. So Sim, so let's take this a step further. Like, let's say that we have this global decentralized network, this gym, right? We're crowdsourcing diverse tasks, verified reasoning traces. We have all these new environments, and it's a huge valuable mode of data, right? Um, how are we feeding that back into the world? Like, do you envision that goes into one open source model? Do you envision it goes into many open source models? Like, how does that train AI for the betterment that we're all using?
Yeah, that's a great question. It's a very big one, and I think you're going to get a lot of different answers. And there's this concept of one global open source decentralized world model that I know a couple of different teams are working on, where you could end up with the architecture that would support this of continuous improvement. So you could constantly be generating new synthetic data, new traces, always feeding that back into the model. And instead of doing sort of these one-off pre-training runs or post-training RL runs, have that data always going back into the model and constantly improving, and having sort of this one model that sort of one decentralized network supports that anybody could access. I think that would be really cool. I think I have sort of this soft hunch that that's where this industry is going to go, whether it's decentralized or centralized. There's going to be sort of new architecture that can support that. I've been a bit recently geeking out on the idea of highly modular sparse models and sort of the ability to have different, very small, more specialized models that are constantly being trained and improved in their one narrow domain get fit together and plugged together. And I'm happy to talk about that at some point, but I think that there will be systems where you can continually get a bunch of really sort of specific data, use that to train these sort of niche expert models, then fit them together and to make a sort of super model. But that's sort of some new stuff that I've been slowly looking into.
No, it's exciting, right? I mean, historically, I always thought the world would sort of fracture into like millions of fine-tuned models, and then your handful of open source and proprietary, mega models. And then I recently became a RAG maxi because I built out a vector database for our fund to reference past plays, and it sort of shifted me a little bit away from fine-tuned models to just large models with that vector call to that database. So this seems a little different, but it yeah, it's hard to form a new worldview and keep up.
Yeah, I don't know. I mean, I don't know if it will derail us too much, but it seems pretty relevant. I think I might not commit myself to it right now, but I have been planning to write my next piece on modular mixture of experts models, with the idea being, right now, sort of there's this model architecture, MOE, or shorthand, sparse models versus dense models, where you basically have these sort of areas of the model, these subsets of parameters that are focused on one domain, like math, writing, etc. It's still one unified model, but only a certain sort of subset of the parameters of a model get activated when it's inferencing. So it sort of roughly, but definitely not one-to-one, but it sort of roughly like mirrors the human brain, where there's different parts of your brain that are focused on different types of tasks and different types of problem solving. And the idea has been, can we end up at a place where we can have these sort of experts within the model be more plug and play? Can we pull one out, update it, improve it, plug it back in? If somebody develops a new expert that is, phenomenal at, I don't know, long-term world context planning or coding in a very, very niche language, can we develop that expert and then plug it back into the model, like almost like a Lego block? And that would allow for like a lot of interesting experimentation for sort of these smaller, more nimble models, experts to get sort of developed by specific research teams and then plugged into other people's models. Because right now you can't do that, and they all need to be sort of trained at once and sort of fit together in unison. But there's been a lot of cool, smart people I've seen slowly talking about this, where I think that might be where the industry is going, and would therefore unlock this new paradigm where there's all of this experimentation and innovation happening around these sort of sub-experts, where people with different specialties could make their expert really, really good and then get used by other people.
Yeah, that's a phenomenal thesis. I mean, my first principles view is just having that narrower and or more modular endgame where the models just don't have to generalize about the world and could either think in just that one narrow domain is where you sort of get the juice per area. But we'll see. I'm curious, like, so the window has shifted so many times. Like a year ago, it was, we cannot beat OpenAI. Decentralized trading and crypto AI and open source is cooked. And now you have Sam and the Anthropic founders literally talking about decentralized data. You have these prime intellect runs, the Jensen runs, the news releases. You have your report. Like, you have this huge shift from pre-training now to inference time compute, right? Reasoning traces.
Mm-hmm.
Has all of this changed your worldview on open source versus proprietary AI?
I wish I could sit here and tell you, like, yes, 100%, it's decentralized AI all the way. I'm not quite there. I think I'm I'm a bit more measured. Where I'm at is that distributed AI is inevitable. And when I was writing the piece, everybody knew the frontier labs were doing distributed runs, where you would have multiple data centers being able to do pre-training in a distributed way. It's not full-on decentralized, where you have heterogeneous compute on in a trustless environment where anybody across the world can contribute it to a training run with anything from an H100 all the way down to a MacBook or an iPhone. So we're not quite there, but distributed AI is very much a thing, and it's also, to be clear, particularly well suited to the RL context, because you can get away with a lot more asynchronicity, and it also needs more parallelization. So it's great for sort of lots of workers working in unison on different types of hardware, and Prime Intellect and Jensen have both shown the efficacy of that with their recent launches. I still wonder about sort of the need for tokens, for sort of speculative incentivization with all of this. I do think there is something to what Alex is doing at Pluralis, where you can shard a model, keep the model on someone's, or a piece of the model on someone's hardware, and then be afforded rewards based on model usage, given how much compute you contribute to a run. I think there is something there. It's just, will the model that this network can train be used enough for it to be valuable? And then sometimes I just worry, like, are we really going to be able to beat the models that these frontier labs are putting out? Because they're pretty effing good. But I would like to hope that sort of with this focus on sort of creativity, exploration, diversity of contributors, we could get sort of better, more interesting models.
Yeah, I think that's a fair take. I think it's I mean, I don't want to give my whole thesis because I have more questions for you, but I'm
Sure.
definitely bullish on the open source crypto AI side. It is hard to contextualize like that part of the thesis though, right? Like the just openness and global access of people to use, iterate, and own, like logically should lead to a better outcome in the open sort of token owned route. But
Mhm.
there obviously are these Goliaths that have clearly better tech right now, like the OpenAIs of the world.
Yeah, and the incentives for them are to, pull up the ladder behind them, create moats wherever they can, right? They're not going to want to allow you to port your data wherever you want, right? They're trying to lock you in to their models, and they want to make it as hard as humanly possible for anyone to leave their ecosystem. That is what worries me. And for a long time, I'm sure you heard this too, everybody was saying that no one should be in the model game. Well, now with OpenAI blowing out memory, um, oh wait, maybe there actually is something to this model game. And if we can get you completely loyal to this one model that knows everything about you, you're never going to want to leave. And so with how fast this is changing, sort of, the incentives leading to a specific type of behavior by these companies, I definitely do worry that maybe we're not going to be able to get people to try, more open source models, at least at the retail level.
Yeah, I mean the lock-in is a real issue, right? Especially with memory. I mean, I get annoyed when I run out of Claude instances and have to copy and paste the entire
Yeah,
combo to my other
exactly.
Claude instance, right? It's
Yeah.
annoying.
Like I used to be like a Claude Maxi, and then OpenAI has got me pretty locked in right now. And like um something would have to be really, really good to make me want to leave.
Yeah, it is crazy though. Like if you build with these models, everyone just thinks like, oh, you can just swap one model out for the other, and it's just like, I mean, I do very basic versions with Bob, my analyst, but
Hmm.
that's an AI agent, but it's really not that easy, right? Like you can't just set the temperature and the top B and K and like throw your prompt in. It's exactly the same. Like these really do become, to your point, like locked into that model. Like everything you throw in that prompt is sort of fine tuned for that experience in that model.
Yeah, for the longest time, people literally thought about this industry like that. Oh, well, you're just going to basically hot swap the newest and greatest model, and there's going to be no loyalty to any model provider. Whether it's open source, whether it's closed source, who cares? You're just going to go after and swap in the best one at that point in time. I don't think any of the executives at these model companies are dumb. They don't want to live in that world, right? They want to lock you in, and they want to make it as hard as possible for you to swap your model. And so, we see that with memory. It's like that's sort of one of the first moves we've seen made to try to increase the ability for lock-in. And I think it's only going to get sort of more extreme as we move forward.
Sam, do you have views on? So I had two hard questions for you. The one was going to be moats for foundational models. The second one was going to be when AGI. I feel like considering they're hard, you could take whichever one you want.
I'll take the second one. With O3, I saw all of these like AGI is now posts, and I was so jealous of people who had that experience because I had the most frustrating experience with O3 possible. I'm not gonna like fully describe it, but I basically have one task that I use for every sort of agentic operator style model that I can get my hands on, which essentially tell the model to go to a company's website, go to the team page, make a spreadsheet with every team member's name and their title. And like an old Gemini deep research model was terrible, like just full on hallucinations, couldn't figure it out. Um, and then like got to try it with Manus, which was going to solve it, but it was going to take almost the entire day, and I like ripped through my free credits in 10 minutes that I just couldn't finish it. But it was gonna get there.
Been there.
And then O3, I had to prompt it like 6 times. It kept failing. It couldn't generate a CSV. I saw other people had this problem too, where like you get stuck in a task loop where it just keeps sending you emails that the task is going to get retried. And so I got like 50 emails in a couple hours. It did eventually get there, but it was like still really buggy. And so like for me, that doesn't feel like AGI. It wasn't that captivating, magical experience maybe some other people had. It's still one of the coolest, best models I've ever used. It's amazing, but I'm definitely not saying that AGI is here right now. I do think though, with the ability to sort of have it learn from all this new interesting tool use behavior and figure out how to string together different um, uh, tools and products and interfaces that it can use, like that's where we're going to get to like extremely useful real world performant model behavior. And I think that will be getting into sort of the AGI territory pretty soon.
Yeah, I mean it's kind of funny you bring up the AGI experience. Like I felt like I had that with the original ChatGPT, and then I read Stephen Wolfram's like ChatGPT explainer, which was excellent, like 2 years ago, and I was like, okay, this is just sort of next token prediction, right? Like everybody
Yeah.
knows this, and then it kind of a little bit like faded for me. But with O3, I didn't have that, oh shit moment like I had with ChatGPT original, but the concept of these reasoning traces and just figuring out how to solve problems on its own from start to finish, like that to me is more obviously like way more AGI like than next token prediction.
Yeah, and again, that's where we're going to get to really, really exciting, like near exponential improvement in model capabilities. I don't know if you read the Arab Experience paper recently, but it's sort of talking about that shift for moving from sort of the more hands-on, sort of human intervention, RLHF environment to just letting these models out into the world, allowing them as access to as much data as possible, as many tools as possible, and just allow them to figure things out themselves with much, much less human oversight. I think that's where we're going to get some very, very cool innovation happening.
Yeah, that is wild. So I mean, on the venture side, like knowing what you know now, are there specific areas you're looking to invest in, like whether it's crypto AI or whether it's just full-blown traditional AI, like any under invested areas that you'd be really interested in meeting teams with?
So we don't do any straight traditional AI investments with Symbolic. So it's all within the world of decentralized AI, crypto AI. Um, I think that there are teams out there right now that are doing incredible work that I'm continually in awe of. Pluralis, Prime Intellect, Jensen, Noose, Ambient, Exo. I'm sure I'm forgetting a couple in there, but those are
That
just
is a hell of a list.
some of my favorites. Yeah,
Oh,
I
those are
love.
all incredible teams.
I know and love all of those teams, and they're really pushing the frontier. Um, it's not really a crypto company, but they're doing cool things around sort of financializing GPU compute. SF compute is really cool. And there's a new team that I've been chatting with who's trying to bring that on chain and then also sort of be able to do sort of really easy to use, easy developer experience platform for linking data centers together and doing sort of distributed inferencing and pre-training and post-training. What I like about it is sort of like, I love the big picture kind of stuff that Pluralis is trying to do of like, fully model parallel consumer hardware pre-training runs. Because it's sort of easier to imagine a world where it can be realized sort of more like in the middle type companies. So, maybe it's distributed but not fully decentralized. You can use stables for settlement, for payment. Those types of AI companies I think are appealing to me because they can be used by anybody right now. But if you want to really swing for the fences, I think the stuff that Pluralis is doing is really, really cool.
Yeah, Alex Long is such a great founder.
Yeah.
Really smart, really strong, like well-researched views. So excited to see what he comes out with and what else his team brings to the table, which I'm excited for.
Yeah, and I would just say, what I'm interested in, this sort of modular MOE stuff is I can't get it out of my head. And so if anybody's working on those problems, so Jensen's actually published on it. It also like Jensen had this week where they announced a bunch of stuff and RL Swarm sort of was the flagship thing that people got excited about. But they had another paper, HDEE, which is working on, can we train sub-experts in parallel on heterogeneous hardware and then fit them back together to sort of have this sort of semi-modular model. They published on that. It's really cool stuff. If you're into this, you should go read that HDEE paper. But yeah, if anybody's doing more work there, I want to see it.
Yeah, I actually just had Ben from Jensen on the pod. I mean, what was your take on RL Swarm from Jensen? Like, were you impressed? Were you happy? Is it solving a key issue that we just talked about? Or
I think it's phenomenal. I think it basically proves the thesis that collaboration, like that sort of school idea I was talking about, where you can get models to learn from each other and to say, oh, I'm humanizing them a little bit, but it makes it maybe easier to understand. Models sharing their strategies with each other and saying, oh, actually, the way that you're doing this is the best way to solve this problem. I'm going to learn how to do it that way. So that sort of cross-pollination, that collaboration leading to more performant models is the exact decentralized RL thesis, right? The more collaboration you can have on an open platform, the better models you're going to end up with. And so, yeah, I'm a huge fan of what they're doing with RL Swarm.
I mean, I think they had. I mean, I had them on the podcast the end of March, but I think they got up to what, like a million? Is it a million models or a million users? I forgot what the.
Yeah, I don't have the numbers off the top of my head, but I similarly was just super impressed by how many people were actually using the technology that they've created, and the number of models that went up on Hugging Face was really cool to see.
Yeah, it's also. I mean, it's tangential, but I think it's worth talking that, like, Noose, Jensen, Prime Intellect, Excel, like all the projects that you mentioned and others that are out there that have incredible teams, like all those deep tech or like hard tech crypto AI companies are doing this without tokens, and they still have all this interest. So
Yeah,
it's just awesome to see that organic interest in these projects, right?
yeah, I mean, because they're solving real problems, right? The teams you mentioned, Noose has been collaborating with Diedrich Kingma, who created one of the optimizers that's used in like every single Web 2 training run. Prime Intellect's been working with researchers at DeepMind who created Diloco and have implemented it in the real world. Like, this isn't crypto land, niche stuff that only applies to terminally on-chain people. They're actually solving real problems that are relevant to all of AI. And it just so happens that, at some point we might want to use this tech to exist in the decentralized context. And for that, we're going to need blockchains to coordinate behavior, to potentially incentivize certain types of behavior or reward people for their contributions. But they're starting with, really fundamental, important technological challenges that not just the crypto people, but all the AI people have worked on as well.
That is really cool. Sam, any like last thoughts on like open source AI, on moats, on China versus the US? I know I'm throwing a lot out there to see like what piques your interest, but just curious if you have anything that you feel strongly about that we like didn't cover or you want to talk about.
Yeah, I think that what there's I mean, maybe a couple of things on my mind. The first would be, very recently there was some talk online about RL not actually sort
I'm
of
so
creating
glad you brought that up.
new behaviors in models. I'm still trying to sort of fully wrap my head around it, but my initial take is essentially, so there's this paper, I think it was out of Tsinghua, but don't quote me on that, essentially showing that there's not sort of a big difference, at least as the authors try to present it, between the performance of base models versus reasoning models. What it really showed is that reasoning models are more likely to get the right answer on like their first try at a problem than a base model. But if you give the model a ton of time to think, the base model will sort of roughly get the right answer at the rate the reasoning model does, or in some cases be more likely to get the right answer. And people are sort of touting this as like RL's all fake. There's nothing good here. And that's not true. At least right now, what RL does is it teaches models, it elicits a type of behavior, a type of reasoning behavior that we want the model to do. And that reasoning behavior is great at getting you the right answer fast. So I don't understand how this got sort of construed as RL is dead. RL is definitely not dead. RL got us O3, which is the best model that we've ever had. So I think that's maybe one thing that's been on my mind.
Well, let me just feed that back to you, Sam. So the thought is that RL can get you the right answer on its first try, but it clearly thinks for longer. But if you ask a base model the question, 10 times, you'll eventually get the right answer somewhere in there. But you could spend the same aggregate thinking time between the two, the 10 tries or the one try, but on the base model side, you don't know which answer is the right one.
Yeah, and so with that, if you can imagine a scenario where if you have all these answers and you have like an oracle that is all knowing and can always pick the best answer from all of the ones that base model generates, you wouldn't really need RL to do the reasoning behavior. But we don't exist in that world, so there's definitely still a need for RL to elicit this reasoning behavior to allow us to get the right answers at pass one.
Yeah, it seems like a dumb take to call RL dead. I got to read the paper though. So
yeah, I mean, I think I shared it with you, but there's another researcher who there was one guy on Twitter who was like, RL is dead, everything's a sham, and then an OpenAI researcher just for fun of being like, this must go crazy if you're dumb. So like, it's which I thought was pretty funny. So yeah, RL is definitely not dead. There is something very important in there, which I definitely want to make clear in all of this, which is performant base models. You need a performant base model to have great RL. There's this amazing clip from Dario from Anthropic talking where he says they're sort of talking about their experiences with RL at Anthropic and OpenAI previously. And he has this line where he essentially says, the models were too dumb. The base models were too dumb to do RL on top of. And what we found is that the better your base model is, the better results you're going to get from the RL process. And so there's been, I think, a trend of trying to say that this RL renaissance means the death of pre-training. And that's not exactly true. If we can keep doing better pre-training and getting more performant base models, we're going to get even better rewards from RL. So we want both of those things to work together in unison. So that's really important too.
Yeah, that is super important. Sam, thank you so much for coming on the show. I'll leave listeners with this, and I'm absolutely sure we'll have you on again soon for your next post or to debate one of our other AI experts. But I really, really think people should check out your post. I mean, I'm going to link it in the show notes, but for those that may have missed in the beginning, it's called The World's RL Gym, and it's definitely on my top 5 list of reads in this space, and I definitely think everyone should check it out. So Sam, thank you for making the time.
Thanks, really appreciate that. Happy to chat with anybody on any of these topics more. Hit me up on Twitter. Hope you enjoyed the piece.